In this Jing video, we're going to talk about how to create a gear using design table in SolidWorks. The particular gear we're going to work on will have a pitch diameter of 5.5 inches, a diametral pitch of 6. The diametral pitch, of course, is the number of teeth per inch of diameter. Has a pressure angle of 20 degrees, addendum of 1 over P, a dedendum of 1.25 over P. Of course, the dedendum always needs to be larger than the addendum so that you have clearance between the top land of one tooth and the bottom land of the other tooth. Fillet radius of 1/16. We're also going to create a series of points and a face width of 3/8 and a center hole diameter of 3/8, and we'll use this naming scheme here: pitch, diameter, addendum, so on, and then x1 and so on. So we'll end up with a gear that looks like this. Again, here's the pitch diameter, 5.5 inches. The pitch diameter, remember, is a very important diameter. You can't actually see it on the gear, but the pitch diameter is used, for instance, to determine the center-to-center distance between two gears. Two gears will rotate as if they were friction cylinders rolling at the pitch diameter. So if you had a pitch diameter of one gear with 3 inches and the other gear had a pitch diameter of 1 inch, then the ratio between the axles rotation would be 3:1. So anyways, this will be what we'll end up with at the end. Okay, so here's a solid model of the finished gear, and if I click on the original sketch here, you can see here are the different circles. Right, this is the pitch circle, this is the addendum circle, the 1 over P, in this case 1 over 6 inches, 1/6 of an inch. That's the distance out from the pitch circle to the addendum circle. The dedendum circle is down here at the bottom land. This distance from the pitch circle to the dedendum circle is 1.25 over P. And then this other circle here, again, the circles that you could actually see or measure on the gear are the addendum circle where the top land is and the dedendum circle where the bottom land is. You can't see the pitch circle and you can't see the base circle. The base circle is the circle that is used to create the involute curve, which is this profile right here. In other words, if you had a string wrapped around the base circle and then tied a pencil to it and kept it taut and unwrapped it, you would get this profile right here. So I'm going to go ahead and actually open the sketch here. And so what we need to do then is create a series of points, and we'll give them names, the dimensions x1, x2, and so on, and y1, y2, and then we'll create a design table and put in the equations for the x and y coordinates for an involute curve, and then generate this curve right here. And then we have to create a mirror line. So one of the characteristics at the of the tooth thickness at the pitch circle is that the width of the tooth, or the circular width here of the tooth, will be exactly equal to the width of the space between the teeth. If you go further out, then of course the width of the tooth is less than the space between the teeth. And if you go further in from the pitch circle, then the distance or the space between the teeth is less than the width of the teeth. So anyways, that's you can see we have the x values, x1 through x11 and so on, and then whoops, the y values over here as well. Okay, so I'm going to stop this video now and pick up with the next video.